Hi! Today I'll tell you about digital and analog signals.
To illustrate that, I'll be using a simple character
Hello, it's me.
who is about to die in a dungeon. Some colored water, a pencil, a gas torch, some stairs, and a hill. Take a look at this rocker. It can move up and down. There are contacts right here. Let's put a ball inside it. And here is our pretty little LED. If I push the rocker down, the ball rolls and closes the contacts. The LED goes on. And if I pull it up, it opens the contacts. The LED goes off. Let's draw 1 here and 0 here. Now you can see a simple digital signal. There are no other options. It is either 0 or 1. Digital signals were invented by humans. There is hardly anything similar in the world of nature. Now let's see how heat works. I start heating that thermometer. The gas torch is pretty far from it, so the temperature is rising slowly. I hold it closer and the temperature is increasing at a much higher rate. It is an example of a simple analog signal. No matter quick or slow, the temperature doesn't jump from one mark to the other. It changes gradually. Okay, imagine stairs. You can jump from one step to another, but you can't move half a step up or down, or you might fall. However, you can go up and down a hill gradually, at your own pace. Arduino, as most computers created by humans, works exclusively with digital signals. In order for it to understand the language of analog signals, it requires an interpreter. Let's see how such interpreters function. We'll need a syringe, water, it is colored for more contrast, and a flask model like that. The scale on the left is voltage, 0 to 5 volts. The scale on the right is digital scale from 0 to 10. Inside the model, there are pairs of brass contacts. I start to fill it with water slowly. The water closes the first contact pair. The first LED lights up. The voltage is now half a volt. Add some more water. Here goes the second pair and the second LED. The voltage now is 1 volt. I keep pouring water. The third pair, 1.5 volts. The fourth, 2 volts. Look, these contacts are the steps of the stairs and the water is the analog signal. The water goes up gradually and the interpreter counts the steps it reaches, thus converting analog signal into digital. Inside Arduino there is a special device, ADC, analog to digital converter. It receives analog input and converts it into digital output. However, you can't see that hardware as it is concealed inside the chip. And one more thing, you can't really notice at first glance. Look at the model. There is no water and that is a signal too. ADC treats it as 0 state, so the LED is on. This model has 11 stages, while Arduino has 1024, and the voltage from 0 to 5 volts is divided in those 1024 stages. There will be quite a lot of lessons with experiments and cool electronics in each of them. You can go wandering around some stores, looking for particular components separately, or you can get them all at once on our website. There you can find everything we use for the lessons, like Arduino Uno, breadboards, resistors, transistors, diodes, buttons, electric motors, servos, potentiometers, wires, loudspeakers, displays, and much more. By the end of the course, you will be able to easily understand not only the basics, but even the advanced microelectronics. You can find the link to our website in the description below. Now, I'll tell you about the potentiometer. Here is what it looks like. For you to fully understand how it works, I made a little bench. It has sandpaper across and contacts on the sides. Those can be rotated to put electricity through. Any battery will do for that. I also need a pencil. I rub graphite on that sandpaper. I got a pretty thick layer. I connect those contacts to the graphite, positive and negative. It is now conducting electricity, though far worse than metal does, due to the high impedance. It is like a resistor. Let's pretend there is a certain character struggling to escape some dungeon and there is no other path. He has to go through those spikes, losing health, and we can help him extract at any point with a ladder. For example, right here. The character would have about 50% of his health left. If we hesitate and extract him here, he would have only 25%. That graphite stripe is the spikes. The electricity runs through while being affected by the impedance. So the voltage gradually decreases, like it is losing health points. At the third contact, the extraction ladder. If it is put in the middle, the voltage is down to 50%. And if I move it here, to 25%. Inside the potentiometer, there is a similar graphite stripe, but it is rounded. Rotating the knob is like moving that ladder. It lets us adjust the voltage to the desired level. Now let's put that to practice. Remember the digital signal of that ball on a rocker. No matter the angle, the LED would be either on or off. What if I put a potentiometer into that bench? I take the knob out and put in a rocker instead. Now we can not only switch the LED on or off, but also change its brightness. The potentiometer tracks the rocker's position and changes the voltage accordingly. The voltage changes gradually, and it is the main difference between analog and digital signals. Next, we'll do the same thing on the Arduino. I put a potentiometer in a breadboard. One wire goes to the ground, and another goes in 5 volts. Take a look at those pins, A0 to A5. A stands for analog. Only these pins can work with analog signals. Insert the third potentiometer contact in A0. Put in an LED. Add a resistor, one leg to the LED and the other to a positive bus. Now connect the LED to the ground with the wire and the resistor to pin 11 in Arduino. The circuit is done. Let's get to the programming. So Arduino should read the potentiometer's voltage and light up the LED with the corresponding brightness setting. As you can remember, the pins connect as both inputs and outputs. The first line says, set pin 11 as an output. The second line, int, allocates a certain amount of memory in Arduino. Let's pretend we put a box in its overall memory and put numbers there. We name that box rotation. The third line says, put a number from pin A0 into the rotation box. That is where the potentiometer comes into play. As you remember, when rotated, it outputs an analog signal, which is then divided by ADC into 1024 stages. So, by rotating the knob, one puts number from 0 to 1023 into that box. The fourth line of code allocates yet another box in Arduino's memory. It will store brightness data. In order to understand what brightness we have, we need line number 5. It says, look in the box rotation, grab a number and divide it by 4. But why would we divide the rotation? We need it for the last line of code. It starts a pulse width modulation PWM on pin 11. As you may have learned from the previous lessons, PWM can change an LED's brightness in Arduino, and PWM only has 256 stages. Done! Now I can change the LED's brightness by rotating the potentiometer's knob.
In the next lesson we'll play with light and fire. I'll tell you about photoresistor, thermistor, and a snail called Gary. See ya!